I try to come up with witty titles, and this was like the best I could do in 3 days' time, so this is what you're going to get. Dancing with the Devil, how to bridge your VLANs, intentionally and unintentionally. So this is an overview of the talk. We are going to have a brief overview of what they are, how they work, when you're on blue team, how you use them, and when you're on red team, what that means for you. We're going to go over an example from a pen test that we did, how we managed to get DC, domain controller, if you're new, through a bridge device. And then we wrote an app that, at least on Macs, will stop you from bridging devices. Where's that Linux guy? Is he still here?
Which one?
Oh, that guy, yeah. If you can code, I would be so okay with you porting that to Linux. So.
Well, it's in the language you want to put in C, which is
awesome. So there'll be a GitLab link and all the fun stuff at the end. And then we'll follow up with the CTF and questions. Okay. So what are VLANs? These are virtual local area networks. Now, what we do with them is segment networks, split things up logically. The usefulness of this is, one, you don't want your IP phone talking to the Kerberos server, maybe. And say you have accounting as a department. They might be spread across all sorts of physical locations, so being able to group them regardless of where they physically are is useful. And it is useful for also reducing the size of a broadcast domain. So for those of you who understand networking, if you have a multicast and you hit the broadcast domain, it repeats that out of every interface on the switch. If you have a massive switch, things can get saturated really fast. You use VLANs to make them smaller, scalable, more manageable. Okay, so why do we need VLANs? Some of the reasons I described earlier, and here's a little diagram to help you out. Bullet points, logical topology, not physical. Reduce the size of broadcast domains, and for security, isolate things based off of level of access. Now, most relevant to us, though, is that security part, so that's what we're going to be focusing on today. Now, from a red team perspective, we know why blue team likes to use them, split things up, yada yada. But as a red team, they're an obstacle to lateral movement, and we have to find ways to get around them. Now, the easiest way is to see if there are any Cisco devices that are relatively old, like that router. They have flaws in their implementations of the link layer discovery and VLANs, DNS. So you can trick the router into bridging it for you through inter-VLAN routing, or just take over the router entirely, and it doesn't matter anymore. So always be on the lookout for that. We can also leverage protocol weaknesses that aren't necessarily vulnerabilities, they just didn't think of them when they were designing the protocol. A good tool is your Cinia. It allows you to manipulate the interface. So we can lie to the switch if dynamic trunking is enabled and pretend that we too are a switch. We can also manipulate what VLAN tag we've been assigned. It's like a number, 1 through, I think, 4096 on most implementations. So restart the interface, let your Cinia control it, change your VLAN tag, maybe change it to a tag that's not on the switch. What will happen? Well, the switch is going to say, I don't recognize what VLAN that is. I'm going to forward it to the next switch, maybe he knows. And if that VLAN is on that, now you have access to that one. So you can also use this to get around MAC whitelisting. On a job, I once saw security cameras that had, they were PoE security cameras and the cable was just dangling, so you could unplug it and just plug it into your laptop. They didn't use MAC whitelisting on the switch, so we could at least move around within that VLAN. Again, dynamic trunking. If it's enabled, that's your go-to. So this isn't in a wild example, a relatively recent pen test that we did. We literally had this exact configuration. A lot of the hosts on the network have been omitted and the topology simplified for this, but it's how we managed to hop VLAN between wired and wireless in order to gain access to the domain controller, which had logins filtered only to wired addresses. Okay, so for those of you who are seasoned in Red Team or Blue Team too, you know how important the domain controller is. If you can compromise the domain controller, you kind of, as a defender, have to make the assumption that the entire forest is compromised unless you can confirm otherwise. So we already knew where the domain controller was, but we couldn't log into it. Whenever we tried to use Remina in order to log into the RDP, it just wasn't listening. There was nothing there. So we assumed that the device that we had compromised for our initial foothold, being wireless, was the problem. We had data mined the device we landed on, and we found some emails where they were referencing the DC server and RDPing, so we knew it was there. Just had to figure out a way to get into it. In our case, the VLAN that we were dealing with is host isolation. The wireless is placed in a separate VLAN from the wired devices. It's pretty common stuff, you'll see it often. And the trick to getting around these is to find the devices that are bridging. Now, if you've seen me up here talking before, you know that most of the work I do is centric to Apple devices or Linux. And for user devices, Macs are just far more common, so that's where most of my examples end up being. Now, laptops are my favorite for this sort of thing because in a lot of work environments, people have docks. They plug it in, they get wired internet, and the wireless interface doesn't turn off. You can still ping it, access services via the wireless. So we have to find devices that are in that state. And we have to find ones that are running services we can interact with to gain access on that device. Now, when you're dealing with a Mac, the easiest way of doing that is Bonjour, or ZeroConf, I think it's called for the Linux folks. It is a discovery protocol that allows hosts on the network to find each other and advertise what services they have on the network. Fun fact, Windows devices will do this too if you have iTunes installed. So, if you know that they use iPads, it's almost certain that some of those devices have iTunes on it. So, you can use a command on macOS called dig to craft queries in order to manually poke around the network and figure out what is there, what is listening. And if you combine that with something like Yersinia, you can hop out of your VLAN, run a dig query, and then collect what's on that VLAN, move on. And then when you start seeing devices with the same host name on different VLANs, you know they're bridging. So when you get a catalog of everything that's on the network during your reconnaissance phase, you know you can't attack everything that's on it. One, if they have an IPS or IDS, it's going to notice pretty fast that you're like fire hosing the network. When you're attacking via wireless, you have a little bit of an advantage because you get banned, okay, swap out your MAC address, re-authenticate with the AP, and try again. Somebody's going to notice eventually though, so you're not doing this on a weekend. Yeah. Now, using dig, we found some devices with services running on it that could have been useful, one of them being SSH. And we had done some OSINT beforehand to figure out who worked there. Now, when the host name that is being advertised in Bonjour contains the name of their IT admin, you know that's a pretty good device to try and target, especially if it has OpenSSH running on it and password authentication is enabled. So, yeah, at that point, you know it's only a matter of time. And we can run Hydra longer than they can, I guess, stay aware of what you're doing, because nobody's going to be watching that stuff 24/7. So, that's what we did. Brute force it with Hydra. Now, a nifty thing about macOS, a lot of operating systems will limit the number of concurrent unauthenticated connections on OpenSSH to like 6. macOS gives you 10. So you get an almost 2 times speed up attacking over something like Linux or Windows if they are running Windows 11. And it took about 14 hours. I won't tell you what his password is, but it was in RockU, so you know how bad it is.
That's bad.
And that gets worse. It gets worse.
This guy is running SSH on his MacBook?
It is a MacBook. Yes.
Okay.
There are reasons why he was doing that. For those, has anyone heard about the ILO series of vulnerabilities, HP's integrated light out? Those were so bad. We had a client that had integrated lights out installed in their environment. It was so old, and given the other indicators of compromise we found in other places just while doing the vulnerability assessment, we told them throw it in the garbage, because for those of you who don't know, the vulnerability in ILO allows you to gain control over the board management controller and flash firmware. And when you have resident firmware, like, I guess that's lower than a bootkit at that point, you cannot assume that just because you applied the patch, it's gone, because it could just lie to you and then say, oh yeah, I'm up to the newest version now. Goes in the garbage. That's why it SSH enabled, because he didn't know, I guess, the difference between the client and the server versions, so he just turned it on. Okay, so after about 500,000 guesses, we get our password, and we log in. Now, I would like to pause for a minute. I know I mentioned earlier IPSs and IDSs are going to be a big obstacle to you when you're trying to move around laterally and hop VLANs, because it's noisy, right? When a switch sends up an alert that it has an invalid MAC address for what is supposed to be on that port, that sets off flags. So we try to avoid doing that if we can. We also try avoiding using tools out of the box, like Beef XSS is a good example. It literally sets beef cookie. So if you just block that in your browser, you're immune to the default Beef XSS. Who actually changes that? Yeah. So if you can avoid using Metasploit, don't use it. It's a lot quieter if you use SSH, VNC, RDP, tunnel it over SSH, especially if they're expecting that traffic on the network to begin with. And his password was also the password to something else. It gets worse. After we'd landed on the device, we ran ifconfig just to see, and yes, it was bridging. We could confirm that much. So when you have administrator level OpenSSH, you can kind of assume you have persistence at that point. It's so easy to do. If you were listening to my last talk, I actually covered persistence methods on macOS. There are plenty of them. So we got the DC because they use the same password for their login on the local admins on the user group, whatever. But we have a pretty good working relationship with this particular IT admin. So we thought, okay, what if we pull this chain a little bit? So what if we remote SSH into his Mac, we enable the built-in VNC server on the Mac, and instead of using SSH, we log in through VNC, and then we log into remote desktop and gain the DC again, just because. And it's really stupid, but you can use this in an actual attack. Especially if you're trying to make it fuzzy about how you managed to get it in the first place. So we leave them a little thank you note on the desktop. leave a note on the DC to let them know that we gained access in case the logs didn't catch it, and move on. Now, how do we avoid these attacks? Ready?
Sure.
Okay.
It's ready as always. All right, so, oh, okay, that's,
Yeah, that's the next one.
okay, just checking. So we know how these attacks are carried out and how you can leverage devices with multiple network interfaces to hop across networks and VLANs. But how do you stop this kind of lateral movement as a blue team? I can press that. So, anyway.
Don't take that from him.
I know, I'm so sorry about him. Buying a drink, he didn't even
Dang.
Anyways, make sure that you guys secure your switches. It's really easy to do. Make sure you're setting your ports to access mode, disable dynamic trunking, and enforce isolation, whitelisting, as we previously talked about earlier, which I'm sure you guys are all familiar with. Y'all are a lot smarter than me on this topic, I'll tell you that now. And prevent dual interface devices from even bridging in the first place. Also, if your network is relatively static, you should probably be disabling dynamic trunking. Disable all your unused ports, and as far as all of that stuff goes, I'm sure you guys know what you need to do with that. So, you know. And some routers do have the ability to set up IP traffic rules and prevent hops when layer 2 controls do fail. And don't discount the ability of dual interface devices. And he sees this all the time. He tells me about it all the time too. All right, and watch out for internet sharing. Macs do have the ability to share their network connection, intentionally bridging interfaces, and Windows can too, which is not a surprise there. And something that we do want to go ahead and point out specifically is the availability for Macs to intentionally bridge interfaces to facilitate like other connection sharings. And Windows devices can do it as well. So just make sure that you check all of your areas while you're already there. Everyone can create the Wi-Fi networks anywhere with pretty crappy security. So if you do manage Macs, make sure that you disable all the profiles that you can, just to avoid future conflict. All right, so this is how we can go ahead and stop Wi-Fi and wired bridging on Macs at least. We do not have Windows. And the way that we stop it the easiest is software controls. And here's a okay, great. Here's a tool that we wrote. So yeah, we went ahead and made an app for that. It's called BridgeBlock. And these are some of the features on it. Command line version's available. It's notarized by Apple. It monitors all the interfaces on your Mac devices for potential bridging connections, just to make sure that you're safe and secured. It also disables wireless connectivity if wired internet is available. And it also automatically re-enables the Wi-Fi when the wired interface disconnects. So we do have two versions of this, okay? It's a menu bar app for end users and a command line version for administrators. And it's GPL licensed and notarized by Apple, so you know that it's secure. So there is a QR code if you guys want to download it. I don't know, I'm say that's after.
You just open up my phone, take a QR code at a random security meeting.
That's
Yeah.
Yeah,
It is. Hey.
authorized by Apple, so it has to be okay.
Yeah. Wink, wink.
The parking spot was sketchy. That's a little sketchy. Gotta cover our bases while talking about security.
Okay.